Students, this is question number 7. Let me write this down. Functions f and g are defined as follows. Right, so f is heading from x to x squared positive 2x positive 3 for x less than equal to negative 1, and you have another function g that is heading from x to x positive 1 with x greater than equal to negative 1. Now we are asked to express f of x in terms of x positive a raised to the power of 2 positive b and state the range of the function. That is one question. Part B is find an expression for f inverse of x. Now part C is solve the equation g times f of x is equal to 13. Okay, so let's get started. Foremost, let me write the given function. We are given that f of x is equal to x squared positive 2x positive 3. Now what I'm going to do is I'm just going to consider x squared positive 2x positive 3 is equal to 0. You just consider it like that. Now take the coefficient of x. What is that? 2. You divide by 2. What do you get? You get 1. Now add 1 squared to both sides. To both sides of, say I'm taking this as say sum 2. So what do you get? You get x squared positive 2x. Now this 1 squared you had it like this. Okay, you have a positive 3 there, and then on the right hand side you add this 1 squared. So this is how we form the system. Now this is actually a perfect square, so push this to the other end. I can read this as x positive 1 whole squared, right? And if I were to push this to the other end, this will become negative 3 positive 1 squared is 1, which is going to give me negative 2 x positive 1 whole squared. Now remember, we took this as equated to 0. Now since we have taken it as equated to 0, now it's time to bring this back to the left hand. So this is going to be x positive 1 the whole square positive 2. On the left hand side you have equal to f of x. Now you might be asking me why, what is the point in moving this to the other end? Now if in situations where you are asked to solve, then we push the constant always to the right end and perform the simplification. So that's why I wanted to stay consistent. Okay, now what we have got f of x is equal to x positive 1 whole squared positive 2. So we have actually achieved the requirement. Express f of x in terms of x positive a the whole squared positive b and state the range of f. If you want, you can simply state here where a is equal to 1 and b is equal to 2. Sometimes they might ask you find the value of a and b. Now since they're asking us to find the range of f of x, we are given x is less than equal to negative 1. So this means x positive 1 is always positive, right? So this means x positive 1 is always positive. Why it's always positive? Because of the perfect square being present. Now since this is always positive, that would mean if my x is say the least value in this case x is less than or equal to -1, right? So the least value that is possible is x is equal to -1. So if I take x is equal to -1, this means the smallest possible value that the function takes is f of x takes is 2. So that in turn would mean our range of f of x will have the least value as 2. So that will be the smallest value that f of x is giving us as a range for the smallest value for x. So it starts with 2, it moves all the way to infinity. So that would be the range for the function. So we have completed the first part. Now we have to move to the second part. Now what is the second part? Find the expression for f inverse of x. So what is f of x? Let me write this down. Okay, this is part B. We need to find f inverse of x. So f of x is equal to x squared positive 2x positive 3. Now I'm going to rewrite this as rewriting y to be equal to x squared positive 2x positive 3. So this is the way I'm rewriting. Now already we know this is equal to x positive 1 the whole square positive 2 is equal to y. Why? Because we have expressed it, right? See, we have already expressed f of x to be x positive 1 whole square positive 2. So this is the expression I am utilizing it here. Now I need to express everything in terms of or I would say first I need to replace y by x and x by y and then rewrite it for y. So that is the first step. So I need to state that replace x by y and y by x. Okay, so this is going to be x is equal to y positive 1 the whole square positive 2. Next, rewriting for y. Rewriting for y, we get. So this is going to be x negative 2 is equal to y positive 1 whole square, which in turn means y positive 1 the whole square is equal to x negative 2. You push the 2 to the other side, you get y positive 1 is equal to square root of x negative 2. Now you move the 1 to the other end, you get y is equal to root of x negative 2 negative 1. Right? So this in turn would mean f inverse of x is equal to root of x negative 2 negative 1. Right? So that is the solution that we are looking for. Now one important point of observation I wish to mention here is that when you move the 2 to the other end, you are getting square root, right? So square root will produce you a positive and a negative value. Now that would mean f inverse of x will have a positive and negative. Now we cannot mention positive and negative. Only one of these will be accepted. Now which of these will be the inverse? That is given from the definition of function. So by definition you can state it. By definition of f of x, the function is defined only for what? Only for x less than or equal to -1. Right, so that would mean f inverse of x in this case would be negative root of x negative to -1. So that is the solution that you will have to write. Now this is part C. We are expected to solve g f x is equal to 30. Now let me write the function down first. F of x is given to be as x squared positive 2x positive 3, and more so importantly x is less than or equal to -1, and g of x is given as 2x positive 1 and x is greater than or equal to -1. Okay, so therefore g f x is written as g of f of x, which is equal to g of f of x is what? X squared positive 2x positive 3. So this means you have 2 times of x squared positive 2x positive 3 positive 1, but g f of x is given to be as 13. So if I were to take this as some say some 5, so therefore 5 can be rewritten as 2 times of x squared positive 2x positive 3 positive 1 is equal to 13. So this is going to be 2x squared positive 4x positive 6 positive 2 is equal to 13. You move everything to the left. This is going to be 2x squared positive 4x 8 negative 13 is equal to 0. Right. So now you will have to make the subtraction. Apparently this is 1 year, so we need to have that 1 there. It's not 2. Now 6 and 1 7. 7 negative 13. Right, so we need to perform the subtraction. That will give us a negative 6 here. So this is 2x squared positive 4x negative 6 is equal to 0. So we divide by 2 throughout. And that would give us x squared positive 2x negative 3 is equal to 0. This is what we are getting. Now if you were to factorize this, this is going to be producing x positive 3 times x negative 1 is equal to 0, which means x is equal to negative 3 and x is equal to positive 1. But we can only take one of these values. Why? Since f of x is defined only for x less than equal to negative 1, right? So that comes into play. So this means x is equal to negative 3 is the required solution. So that completes the question. So we move on to the next one.